Hello again, students. In the last video, we talked a little bit about radicals and how to determine whether a radical was a rational or an irrational. In this video, we're going to be learning a little bit more about radicals, and specifically, we're going to be talking about entire radicals and mixed radicals. We're also going to develop some strategies to determine the differences between the two types of radicals. Let's get started. Recalling your knowledge of fractions, remember that there's two types of fractions. There are improper fractions and mixed fractions. Improper fractions do not have any integers in front of them, while mixed fractions do. Keeping this in mind, here is an example of an entire or a whole radical and an example of a mixed radical. What do you notice? Well, the entire or the whole radical looks like an improper fraction because it doesn't have an integer in front, while the mixed radical looks like a mixed fraction because it does have an integer in the front. In fact, this is how we can identify the difference. A mixed radical is a number that is a mix of an integer and a radical, while an entire radical is just made up entirely of a radical. Looking at these two types of radicals in front of you, it turns out they are actually the same. Let's turn to the whiteboard and see how it is that they are the same. Okay, so now we're going to be taking a look at our first example, which says to simplify the square root of 50. Well, I wanted to make some notes quickly before I started this problem. When you see the word simplify, it means to change this entire radical into a mixed radical. Note that the square root of 50 is an entire radical, and so we're changing that to a mixed radical. To do so, we're going to be making a factor tree in order to find the perfect squares. So let's do that. Well, I'm looking at the square root of 50, so the number I'm factoring is going to be 50. 50, well, I know that splits up into 2 and 25. And then 25 is a perfect square, but I'm just going to go a little bit further and get 5 and 5. Okay? So that means 50, the number 50, is equal to 2 times 5. And I'm going to note the 2 here, the square, because it's just so important. 50 is equal to 2 times 5 squared. All right. So because I'm looking for the square root of 50, I'm going to have the square root of 50. Well, what's 50? 50 I just found was this number right here. 50 is going to be 2 times 5. I'm going to write the square again in the blue. Okay. This is going to be, well, I can split up the radical actually into the square root of 2 times the square root of 5 squared. Okay. Well, the square root of 2, I learned in the last video, is an irrational number, and I can't simplify that any further. But I know that the square root of 5 squared is this 2 times the square root of 25. Okay, and let's continue that over here. Well, the square root of 25, well, that is 5. So I have that this is equal to 2, the square root of 2 times 5. All right. And so, wait, I can just write that as a mixed radical now. So that means I have 5 square root 2. And that is precisely my answer. So what I just did is I turned the square root of 50 into 5 root 2, a mixed radical, an entire radical to a mixed radical by doing a factor tree. Okay. Let's see how we can do that with another example. Here's a useful rule. The square root of a times b is equal to the square root of a times the square root of b. Or equivalently, the square root of b times a is the same as the square root of b times the square root of a. Note, when we are square rooting a number, we are always finding the principal root, the positive answer. What do I mean by that? Well, let's take a look at an example. The square root of 25 is 5. But if I'm looking for a number x that is squared, that equals 25, I see that x can either be positive 5 or negative 5, because positive 5 squared is 25, and negative 5 squared is also 25. But the positive 5 is, well, it's positive, which means it is the principal root. In pre-calculus 11, though, we'll be working with both roots. Now, let's turn to the whiteboard and try a few more examples. Okay, now that we've learned a few little rules about how to simplify numbers a little easier, we're going to be looking at some more examples, and we're going to do so using two different methods. The first method we're going to be using is just like we did in the previous example, where we're finding perfect squares. And to do that, we're going to make another factor tree. So, we're going to start with the factor tree for 72, and we're looking for a square root. Remember that. So we're looking for perfect squares. So I know that 72 is even, and because it's even, I'm going to split that up into 2 and 36, because 72 divided by 2 is 36. And 36 actually breaks down a little further. It becomes 6 and 6. Right, so I actually see a perfect square right there, because 6 times 6 is 36. So that means 36 must be a perfect square. Perfect square. And now that I have that, I can write the square root of 72 as the square root of 2 times 6 squared, because 72 is equal to 2 times 6 squared, right? And that's what I got from that previous little factor tree. And when I split this up, I'm actually going to get the square root of 2 times the square root of 6 squared. Okay? And when we have a square and a square root, they actually cancel out. So I'll be left with the square root of 2 times 6. And I'm just going to rewrite that quickly because I am looking for a mixed radical. And when we do so, the integer is in the front. That means I have 6 root 2 as my final answer. Okay, so now that we have this method out of the way, let's take a look at our second method. Okay, now we're on our second method, and the second method is called find groups of blank. What do I mean by this blank? Well, depending on the radical we have, we're going to be looking for groups accordingly, and by the radical I mean the index for the radical. Here we're looking for a square root. There's no number there, and when there's no number, we know that's just a square root, so the index is 2. And so, because this is 2, we're looking for groups of 2. Okay? If this was a cube root, we'd be looking for groups of 3. If this was a fourth root, we'd be looking for groups of 4, and so on and so forth. So, in this case, we're looking for groups of 2. I actually see a group of 2 things right here. So this is 2 things. But I'm just going to push this a little further so we can really get the idea. I know that 6 becomes 2 and 3, and 6 is, well, 2 and 3, I just did that. And so when I write this, I'm going to have the square root of 72. Oops. 72. Well, the square root of 72 is going to be the square root of 2 times 2 times 2 times 3 times 3. Okay? You don't necessarily have to write it this long. You can write this as the square root of 2 cubed times 3 squared. Okay? But this helps us really visualize it a little more. And remember I said I'm looking for groups of 2. Well, I see one group of 2 there, and I see another group of 2 there. That means 2 things, groups of 2 things. So these are the numbers I'm going to take out. Take out a 2 and a 3. So I'm going to take out a 2 and a 3. And so I'll be left with, on the outside, I'll have a single 2 from taking out that 2. And I'll take out a 3, so I'll get a 3. And this stays inside. Okay? because it wasn't in a group of 2. So it stays inside because it wasn't in a group of 2. And we're going to get that it stays inside. So we'll have the root of 2 by itself. On the outside, well, I actually have 2 times 3, which is 6. So 6 is on the outside. And I have root 2 on the inside. And that's exactly the same answer I got. So this is another method that we can use to find the square root of 72. Alright, so we've just gone through some examples where we express entire radicals as mixed radicals. And now we're moving on to our next section, which is converting mixed radicals into entire radicals. And to do that, I'm going to write a note really quickly for us to have in our heads. To do so, we're going to be using the index as a power. Okay, let's see what I mean by that. Well, in this question, we're writing 2 root 5 as an entire radical. And remember, the index here is invisible, so we're writing that as 2 square root of 5. And so, when we're converting this into an entire radical, we're using the index as a power. So let's see how that works. I know that 2 squared is the index. The 2 is the index. So I'm going to be left with 4. And so when I bring that in, I'm going to have the square root of 4 times 5. And, well, this is just 20. So I converted 2 square root 5, which was a mixed radical, into root 20. And let's see another example. Well, I'm going to erase this, and this, and this, and this. I'm going to now try this with a 4th root. Let's also erase that. Well, I'm using the index as a power, so I'm putting this 4 here. Okay? And so I know that 2 to the 4, if I type that into a calculator, well, that's going to get me 16. 2 to the 4 is 16. And so I'm going to write a 16 here. And now I have 5 times 16. And typing that into a calculator, well, I'm going to get the number 80. 80. Oh, let's just be careful. I wrote square roots everywhere, but it's actually a 4th root. So the 4th root of 80, if I were to simplify that, that gets me 2 4th root of 5, and vice versa. In this video, we learned a little bit about mixed radicals and entire radicals. In the next video, we'll be learning about fractional exponents. Until then, take care, stay safe, and have a wonderful day. Bye!